specialty. Hello, Mr. Nemo here. We got number 3, probably out of a 4-part series, maybe 5. I hope not to have to do 5, but this one will be a quicker one. You may see a problem on your test that looks like, and I shouldn't say may, you will see a problem on your test that, let me flip through here, not that I'm reading from the test, but if they want to know about maybe the ratio of 2 adjacent side lengths of a rectangle. So say you had a rectangle, looked like that, and this side was 3, and this side was 4. And they gave you his big brother rectangle over here, or sister. That works too. And you wanted to know if x, and we're going to tell you what x is, but you wanted to know if those ratios were similar. Because if we know that if there's similar rectangles, the ratios of the side lengths, this over that, or that over this, is going to be the same thing. So let's take a look at a problem like that. So if we had 3/4 as our ratio, and then I gave you something like, I don't know, 6/12. So we got to say, is that similar to each other? Are they, and it actually turns out to be, are they equivalent fractions? So is 3/4 equivalent to 6/12? Well, how I would do it, maybe that's not how the other teachers showed you, but the way that Mr. Nemo would do it, I would say, I would pick either the 3 or the 4, it doesn't matter, and I would say, how did I get from numerator to numerator or denominator to denominator? So I'll just pick on lonely little numerator up top. How did the 3 become a 6? Well, I had to multiply by 2. But if I take, whenever I do to the top, I have to do to the bottom. If I multiply this by 2, do I get 12? Well, 4 times 2 in my book is 8. So I would say that that is not going to work. Let's do another one, 3/4, and let's look at 5/4. So is that an equivalent fraction? Again, if they share the same ratio because they're similar rectangles, I hope I'm not saying earlier in this video triangles because I do that a lot. Rectangles, the numerator and the denominator are going to be equivalent to each other, so, or to the other fraction. So if I take a look at, well, obviously, real easy, 4 times 1 is going to give me the 4. What is 3 times 1? Well, I hope you're saying and screaming and jumping up and down that it's 3, not 5. So obviously this is not going to work. And let's take a look at one more. How about 3/4 and 9/12? Let's do the denominator again. How did I get from 4 to 12? Well, I had to multiply by 3. Whatever I do to the bottom, I have to do to the top. And what is 3 times 3? Oh, well, lo and behold, it is 9. So whatever I did to the numerator or denominator, I got to do the same thing to either one. If I get something that gives me a solid answer, a real answer, is 3 times 3 9? Yes, it is. Is 4 times 3 12? Yes, it is. Well, then these side lengths obviously could be 9 and 12 because they share the same ratio. Thus, they are similar rectangles. I hope that makes sense. You will see something very similar to that. So know this, study it, and good luck.